Have you ever wondered how clicking a button on your computer screen triggers a specific response? It's a bit like magic, isn't it? But the reality is far from it. This magic is brought to life by a concept known as event handling in computer programming. In the realm of programming, especially when dealing with graphical user interfaces or GUIs, event handling is an essential tool. Applications, whether they're desktop apps or web-based, rely on event handling for interactivity. Think about it. Every time you click a mouse button, press a key on your keyboard, or even move your mouse, an event is triggered. And the way a program responds to these events, that's event handling in action. Let's take it a step further and dive into the world of Java programming. Whether you're using Swing or JavaFX for GUI development, event handling is at the heart of it all. These events can be as simple as a button click, or more complex like keyboard inputs, mouse operations, and even custom events. But event handling doesn't stop there. In the sphere of internet programming, event handling is equally significant. Applications may need to respond to network events such as received data or changes in connection status. This aspect of event handling is essential for creating responsive, user-friendly applications. To give you a taste of what's to come, let's consider a basic example. In JavaFX, to handle an event such as a button click, you'd attach an event handler to a UI component. The setOnAction method of the button class can be used to register an event handler that prints a message to the console when the button is clicked. It's as simple as that. So as you can see, event handling plays a vital role in programming, especially in GUI development and internet programming. It's the secret sauce that makes applications interactive and responsive to user actions. And Java, with its robust event handling mechanisms, provides programmers with the tools they need to create dynamic, user-friendly applications. In the next couple of minutes, we will explore how Java handles these events. So sit back, relax, and let's delve into the fascinating world of event handling in Java. JavaFX uses an event-driven model to manage user interactions or changes in the GUI. This model is the backbone of creating interactive applications, and JavaFX does an exceptional job at catering to this need. JavaFX provides a rich set of event types that you can use to respond to various user actions. These include, but are not limited to, mouse clicks, key presses, and even actions related to touchscreens. You can also define and handle your own custom events, which gives you a great deal of flexibility in designing your application's user interface. The event handling mechanism in JavaFX is robust and easy to use. To handle an event, you typically attach an event handler to a user interface component. This event handler is a piece of code that gets executed whenever the associated event occurs. For instance, let's consider a simple scenario where we have a button in our application, and we want to print a message to the console every time this button is clicked. To achieve this, we would use the setOnAction method of the button class to register an event handler. The event handler in this case is a lambda function that prints the desired message. Here's what the code would look like. In this snippet is where we attach the event handler to the button. The lambda function is our event handler. This function gets executed every time the button is clicked, printing "button clicked" to the console. You can use this same basic pattern to handle other types of events and to attach event handlers to different types of user interface components. The beauty of JavaFX lies in this simplicity and uniformity. As you can see, handling basic events in JavaFX is quite straightforward. This foundation allows you to build complex, interactive applications with ease. So let's dive deeper into the world of JavaFX event handling in the next scene. Stay tuned. But what if we want to handle more complex events such as keyboard inputs or mouse operations? Well, JavaFX doesn't shy away from complexity. It thrives in it. It's designed to handle a wide range of events, from the simple button clicks to the not-so-simple mouse movements and keystrokes. Yes, even your custom events have a place in JavaFX's world. Let's take a look at mouse events. These are a bit more intricate than your basic button clicks. They involve a mouse, and the mouse doesn't just click, it moves, it drags, it double-clicks. To handle mouse events, JavaFX provides several specific event types, like mouse event, drag event, scroll event, and more. For instance, suppose you want to print a message when the mouse button is clicked, and a different one when it's double-clicked. You could use the setOnMouseClick method of the node class and an if condition to check the click count. Here's a quick example. Your code would look something like this: btn.setOnMouseClicked event. In this code snippet, the setOnMouseClicked method is used to register an event handler that gets called when the mouse button is clicked. Inside the event handler, we're checking for the number of clicks. If the mouse button was clicked twice, it prints double-clicked to the console. And just like that, you've gone from handling simple button clicks to managing double mouse clicks. It's a small step up in complexity, but it opens up a world of possibilities for interactive application development. JavaFX's event handling mechanism is powerful and flexible. It allows you to respond to diverse user actions and system events, making your applications more dynamic and responsive. With JavaFX, handling complex events becomes a breeze. Now, let's shift our focus to Swing, another popular Java GUI toolkit. Event handling in Swing, like in JavaFX, is crucial for creating dynamic and interactive applications. However, the approach to event handling in Swing differs slightly. Instead of directly attaching event handlers to UI components, Swing often involves working with listener interfaces. A listener interface in Swing is essentially a contract for classes that want to respond to a particular kind of event. These interfaces define one or more methods that must be implemented by any class that wishes to handle the event. These methods serve as event handlers, defining what action should be taken when the event is triggered. To illustrate, let's consider a simple example of handling a button click in Swing. First, we create a button, then we add an action listener to it. An action listener is a type of listener interface specifically designed to respond to action events such as button clicks. In our action listener, we override the action performed method. This method serves as our event handler, defining what happens when the action event is triggered. In this case, when the button is clicked, action performed is called, and a message is printed to the console. Here's a code snippet to demonstrate. In this example, we've used an anonymous inner class to define our action listener. However, it's also common to have the class that creates the button implement the action listener interface directly. So you can see that while the underlying concept of event handling is the same in both JavaFX and Swing, the implementation differs. In Swing, we use listener interfaces and override methods, whereas in JavaFX, we attach event handlers directly to UI components. As we can see, Swing provides a different yet equally effective approach to event handling. Event handling extends beyond GUIs to internet programming, where applications may need to respond to network events. Picture this. You're creating a client application using JavaFX or Swing that interacts with a server via sockets. This application isn't just responding to user clicks or keystrokes. It's also listening for data from the server and updating the GUI accordingly. Let's illustrate with a simple example using sockets in a JavaFX application. To handle network events, you'd use a background thread to listen to messages from a server socket. When a message arrives, the application needs to respond. But how can it do so without freezing the GUI? That's where the platform run later method comes in. This method ensures that GUI updates are performed on the JavaFX application thread, keeping your application responsive and smooth. This shows how event handling can make a Java application responsive to network events. So there you have it, a comprehensive guide to event handling in Java. We've delved into the heart of the event-driven model, exploring how JavaFX and Swing respond to user interactions and changes in the graphical user interface. From basic click events to complex keyboard inputs, mouse operations, and even custom events, we've seen how JavaFX uses an event handler attached to a UI component, while Swing often involves working with listener interfaces. And let's not forget the role of event handling in internet programming. We've seen how JavaFX or Swing can be used to create client applications that interact with a server via sockets, listening for data from the server and updating the UI in response. Remember, mastering event handling is key to developing responsive Java-based applications, so keep practicing.